Yes, it's a good day from morning till night.
Web navigators, hello and welcome to PC Tips and Tricks. Here's a little hack that apparently might speed up Windows. Does it actually work? And what kind of minimum PC specs does this apply to? It's a classic hack that's been around for a very long time, ever since the days of Windows XP and Server 2003. Whilst it is based on sound technical principles, its effectiveness on a modern PC remains nonetheless highly questionable and may even be counterproductive in some cases. Let's demystify all this a bit. Does it actually work? The answer is yes, but there's a catch. Not quite as you might think. The value LargeSystemCache tells Windows to prioritize the system cache over the application's working memory. In short, Windows will use more of your memory to store recently opened files. This can reduce performance because the system steals RAM from your application to allocate it to the file cache. The size value, LanmanServer, configures memory management for the file sharing service, SMB, which stands for Server Message Block. The size value, set to 3, is designed to improve the speed of the drive by allocating a large amount of space ideal for file servers. On a desktop PC, the impact is virtually negligible unless your PC is used as a storage server for other computers on your local network. Minimum system requirements. There is of course a strict minimum requirement, as applying this to a low-spec PC is risky and will ultimately cause it to crash. The minimum would be 16 GB, and to be on the safe side, if you're looking at 8 GB or less, you'd be better off giving it a miss. Enabling a large cache risks overloading your memory and forcing Windows to use the swap file, virtual memory, which is located on the hard drive, which is much slower. This will slow down the entire system, no benefit whatsoever. Theoretical performance. Here's how these settings affect the system's behavior depending on your hardware. The RAM speed in MTS affects the speed of the transfer, but not the efficiency of the caching process itself. From 32 GB and above, it starts to get interesting: 128 GB of storage. As in my case, we're entering a category where the standard Windows rules no longer really apply. In this specific case, the hack becomes interesting, but for different reasons. Here's why. For a PC with such capacity, the benefit of LargeSystemCache. By default, Windows tries to save memory to prevent the system from slowing down. With 128 GB, you have a virtually inexhaustible memory pool for normal use. The advantage? By enabling LargeSystemCache, you force Windows to use this unused memory to cache all your working files. If you open a 40 GB video project, Windows will keep the entire project in memory. The next time you access it, access will be instantaneous. The risk is that even with 128 GB, Windows can become sluggish and fail to release memory quickly enough if a very resource-intensive program such as a 3D simulation or 8K rendering suddenly requires it. Performance for 128 GB of memory. At this level of memory, the transfer rate, MBS, becomes the limiting factor more so than the amount. Settings and recommended values from 32 GB up to 128 GB. With 32 GB or more, you're in the standard range for Windows. The system becomes much more stable as it no longer struggles to free up memory, which allows it to be more aggressive with the cache. For 32 GB, this improves responsiveness without overloading the memory when running resource-intensive software. For 64 GB, perfect for 4K editing and intensive multitasking. For 128 GB, absolute comfort for virtual machines and large files. With this type of configuration, you're telling Windows not to let your gigabytes of memory lie dormant in a corner. Instead of clearing the memory as soon as a file is closed, Windows keeps it in memory just in case. Your software reopens more quickly and your file libraries run smoothly. This is almost essential for 128 GB. Without it, you would have 100 GB of unused memory, whilst your hard drives would be working unnecessarily. LargeSystemCache allows you to turn your unused memory into an ultra-fast invisible disk. The higher the MTS frequency, the more responsive the system cache will be to the processor. But please note, if you decide to set up this system cache process, you will also need to change the virtual memory settings and set them to managed by the system on all installed drives. Windows uses terms that appear to be synonyms, as they operate at different levels. In the virtual memory settings menu, there is an important distinction. Here's the option, automatically manage all drives. This is the tick box at the very top of the window. The idea is that you give full control to Windows to decide which drive should have a swap file and how big it should be. Generally, with this option, Windows selects the system drive and ignores the other storage media unless it is desperately short of space. This is the stress-free solution. Windows adjusts the size dynamically according to your immediate needs. Size managed by the system on a specific drive. This is the option you need to select manually for each drive. Windows will create a page file sys file on each drive and determine its size in real time. With 128 GB parallel writing, if Windows needs to write temporary data to the drive, it can distribute the load across several drives at the same time rather than overloading just the system drive. It's a bit like increasing the number of lanes on a motorway. Editing and virtualization software often create their own temporary files. By having swap files everywhere, you provide these programs with local overflow areas on each drive, which reduces latency. Automatic management is a so-called convenience option for the general public, whilst managed by system on a per-disk basis is a precision configuration for someone who has a so-called workstation PC. You will therefore have a clean and consistent configuration. By letting Windows manage the swap file across all drives, whilst having LargeSystemCache enabled, you will have created a highly flexible environment for your 32 GB, 64 GB and even 128 GB of memory. In practical terms, here's what will happen: the synergy between physical memory and virtual memory. Even though it may seem counterintuitive to have a swap file of 128 GB, it's the best decision. Regarding stability, some software such as the Adobe Suite or rendering engines specifically look for a backup database on the disk, even if the memory is empty. By letting Windows handle this, you will avoid crashes such as out of memory. As for efficiency, Windows will almost never use these files on the disk for performance purposes, but will use them to move so-called dead data and Windows services that have been unused for hours, leaving all of your 128 GB available for your active applications and the file cache. What to look out for? After a few hours of intensive use, you should see the cached value rise much higher than before. Windows will gradually fill your memory with data from your drives. A quick safety reminder: as you now have a system that relies heavily on memory for writing and file management, you must avoid forced shutdowns at all costs. For example, by holding down the power button or unplugging the power cable, you risk losing some data. Your PC is now optimized to make the most of its excessive hardware. With these settings, your PC moves up a class. It goes from being a powerful PC to a genuine workstation. You will, however, need to keep an eye on the temperature of your memory. 128 GB of memory can generate a significant amount of heat when operating at 80% or 90% capacity. Ensure that the airflow within the case is sufficiently efficient. Here's how this hack will indirectly affect the thermal performance of your NVMe SSD. If your operating system is installed on this type of storage medium, the reduction in the number of write cycles. The principle of LargeSystemCache is to keep data in memory for as long as possible rather than immediately writing it back to the drive. Without this optimization, for every small change made during video editing or photo retouching, Windows tends to write to the SSD very frequently to secure the data. Every write operation requires energy and generates heat at the heart of the NAND chips and the controller. With optimization, this reduces the number of electrical transfers to the NVMe SSD, less strain on the NVMe controller. The component that heats up the most on an NVMe SSD is not the memory itself, but the controller. It is the small chip that manages the data. By using the memory as a buffer, you reduce the computational load on the controller of the NVMe SSD. Since the RAM handles a large proportion of repetitive read-write operations, the SSD remains in a state of low power consumption or relative sleep more often. The crucial role of the swap file or virtual memory configuring swap files as system managed across all drives also helps, as instead of concentrating all the heat on a single storage medium, Windows can distribute virtual memory writes across your other drives. The thermal load is spread across the other storage devices, thereby avoiding thermal throttling. The slowdown of the SSD when it exceeds 70-80 degree optimization is particularly helpful in reducing the background heat during precision work, such as editing, post-production and browsing. With so much memory, it's as if you'd installed a huge thermal buffer between your software and your storage hardware. Pure bliss. You will also notice when you shut down your PC that it takes longer to shut down. This is because the system management has been activated for all the drives. Therefore, several paging files or virtual memory files have been created on each existing drive. It therefore takes a certain amount of time for all of them. Right, enough talk. To start with, we're going to open the registry editor, Regedit. Click on the search icon and type the following into the search bar. Run as an administrator. Here we are. Copy and paste the path shown in the description. Then press the Enter key on your keyboard. Search for the value LargeSystemCache. If it does not exist, create a new 32-bit DWORD named LargeSystemCache with a capital letter at the start of each word. Double-click the value data is already highlighted. Set to 1 to enable, then click OK. There you go, that's it. You must save the modified key. Right-click on the memory management key, select Export, open the path to your backup folder, then name your backed up key so that you can easily recognize it. Then click on Save. Copy and paste the second path that is specified in the description. Then press the Enter key on your keyboard. Search for the value size. If it does not exist, create a new 32-bit DWORD value named size with a capital letter at the start of the word. Double-click on the value's data is already highlighted. In my case, I enter 2 for the defined size, then click on OK. There you go, that's it. You must now save the modified key. Right-click on the parameters key, select Export, open the path to your backup folder, then name the saved key so that you can easily recognize it. Then click on Save. You can close the tree view and exit Regedit. That's done. Let's now move on to configuring virtual memory or the paging file. Open the Windows settings. Click on the settings icon. Select the System tab. Scroll right to the bottom. Select System Information. Then Advanced System Settings. Alternatively, type System Settings directly into the search bar and click on the result that appears in the Performance section. Click on Settings. Then on the Advanced tab in the Virtual Memory section, click on Change. Select one of your drives to be indexed as size managed by the system. Then click Set and repeat the process for the others. Once done, click OK. Then OK. Here is how the system cache will behave depending on your usage. It will gradually fill up. This is for those who might be afraid to go into the registry first. Copy what is indicated in the description directly into the folder where you are going to save this newly created file. Right click, select New, then Text Document, and you need to name this file so you know what it corresponds to. And we'll also change the file extension from .txt to .reg. Click in the window, click on Yes. Right-click on the file, select Edit in Notepad. Paste what you previously copied. Now select File, then Save. And give it a quick try. You will need to restart your PC for the changes to take effect. And when it restarts, it will be a new PC that you are about to discover. You now have an improvement to your operating system. Don't forget, however, that all existing hacks must be carried out on PCs in good working order. By this, we mean good ventilation and efficient hot air extraction. A clean case and its components, thermal paste for the CPU and GPU changed regularly, software drivers kept up to date, and Windows as well. I hope you enjoyed it. See you soon in the next video.